Hello everyone, here's a worked example from topic 7, or on topic 7. It's similar to the review question 4, and basically it's the same as a lot of the questions throughout this. It's where we've got two linear models and we're looking for a crossover point. So the basic idea of when we have two linear models, so for instance if we have 3x plus 7 and equal to say x minus 2, and both of these equations can be plotted on a graph. The 3x plus 7 sort of looks something like this, and then the x minus 2 would look something like, starting from -2 and then going up by x, would look something like this, so it's going up at a lower rate, and they would have some crossover point, in this case maybe down there, and we're trying to find the value of x for which they cross over. But the context of this one is that we've got two petrol stations, and one of them sells petrol at $1.49, cheap rate, and the other one sells it for $1.75, but they have this $5 off if you spend more than $20. And the question we're asked is, how many litres of petrol would we need to buy for which they're the same price at both of them? And then of course you could use this answer to say, okay, so if it's greater than this value, then clearly going to the cheaper price per litre would be better. If it's less than this value, then going at this $20 off would be good. But there's a slight twist on it because we only get the discount when we have above $20. So, but we proceed in a similar way to we have before. So I've got the K petrol and the S petrol. So the cost, so I'll write this CK, which just means the cost, at this petrol station in terms of how many litres we get would be 1.49 L. So L is my variable here, and it's the litres of petrol. And this just stands for the cost. For S petrol, we have something slightly different going on. So I have, usually my cost at S petrol is just going to be 1.75 L. And if these were the only costings, then there's no number of litres other than 0 litres for which the costs would be the same. But then we also, for this one, have another cost, another alternative, which is 1.75 L minus the $5. Okay, so the key thing here is that we need to know, well, when do we use which model? So actually we need to have a number of litres, at which we start deducting this $5. So we can just do our $20 and we divide it by 1.75, and this will give us approximately, I think, 11.43. And so this is the number of litres that we need to buy before getting a discount, before getting the $5 off. And so that helps us put the constraints on these models here. So it's going to be $1.75 litres if L is less than 11.43, and then it's going to be $1.75 times the number of litres minus $5 when L is greater than this 11.43. Okay. Okay. So then what we want to know is, for when are the number of litres the same? So we have our two equations which give not this one, sorry, I want this one and this one. And we want to know when the cost at K is the same cost at S. So we've got, when does $1.49 per litre become the same as paying $1.75 per litre and subtracting 5? And so this, once we've got it in this form, we see we've got two equations, we've got a single variable, so the variable is here on both sides, and we just need to do our methods to rearrange this equation and find the value of L. Again, a few different ways to do it. We can move, the first step, as I said, with all of these types of equations, is we can move this over to this side, essentially, or eliminate the $1.49 L from here, so that we just have L on both sides, or we can move this one over here, which is an appealing prospect in this context, because then we'll have less to solve. So I might do that. I'm going to first subtract $1.75 from both sides, $1.75 L from both sides. Remember, I have to do it in terms of this variable, because otherwise I won't be able to eliminate it on this right-hand side. So that would give me 175 minus 149 is negative 0.26. So I get 0.26 L, don't forget the L, because we subtracted this much L, and that's equal to negative 5. And then in order to get L by itself, since I'm multiplying negative 0.26 times L, I need to divide by 0.26, and then that will give me L equals negative 5 on negative 0.26, which is approximately 19.23. And so this is the number of litres that I would need to buy before going here is the same as going here. And one additional thing, I just make sure that this is actually relevant, is valid for this model. So that enables me to see what is going on there. Now, having done it this way, so this is sort of the very rigorous way of going about and doing it. But another way that we could look at this problem, so let me just get rid of, I'm going to use that again. So let me just get rid of all this for the moment. That's where I'm going to be heading. Yeah, that's okay. Have new space. The question we're asked is, when is it going to be the same price here as it is going to be here? And it basically means, for what number of litres is this negative 5 going to change this rate to 1.49? So since we know that it's a difference is 0.26 per litre, I basically just need to know, again, how many 0.26 is going to 5, because once I've got that many litres, well then the $5 just cancels out that much. So since it's 0.26 more per litre, I say, well, once it gets to, again, it's going to be instead 5 divided by 0.26 equals 19.23. And so once I'm here, it just means essentially once I've bought this many litres of petrol, the $5 will account for the fact that I'm paying an extra 0.26 per litre, but then I'm going to keep on paying 0.26 per litre. I'm going to be above on that one. So, the key things here are setting up the price. Now, one of the ways that when we go about setting up the price is you can substitute values, make sure that it makes sense. So, the tricky thing here was we needed two models. Hopefully we can see that, here we're paying $1.49 per litre, so as soon as we know the number of litres, we just multiply that by 1.49, so that's why it has this form. Remember, there's an implicit multiplication in here. But then for this one, we needed to say, well, chuck in a few values, so when L equals 10, then I'm going to be paying $17.50 at this place here, and I wouldn't get that saving yet. But then once I get to, say, 12, then I know that I do get that saving and the price has changed. So, hopefully that helps clear up this type of question. The key thing is being able to set up the models and then being able to do that solving of those two linear equations. Cool.